Alright, so I will be giving a short video presentation on my case study topic, which was measurement devices used in modern CCPPs for the course Industrial Instrumentation and Measurements. My partner for this case study was Ahmed Ali. So the aim of this case study was to research about the different types of measurement devices that are used in large-scale power generation stations like the one present at Karanki Power Complex, which is run by K Electric. This was done to add an extra layer of context to what was already covered in the course and to understand how these measurement devices are used practically in large-scale industrial environments. So in this presentation, I will be giving a short introduction on what are CCPPs, a little bit about KPC, and what are the role of programmable logic controllers at the plant, and then we'll be talking a little bit about the different sections of the plant, like the gas receiving station, the natural gas compressors, and so on. So what is a CCPP? So a CCPP stands for Combined Cycle Power Plant, which are basically generation stations that have both a gas turbine that is fired by natural gas, as well as a steam boiler and turbine that uses the hot exhaust gases from the gas turbine to boil water to generate electricity. So you might see something written here, which is HRSG, which stands for Heat Recovery Steam Generator, which uses the hot exhaust gases from the gas turbine to produce steam for the steam turbine. And this is primarily done to increase the overall efficiency of the plant. So K Electric states that it increases by up to 5%, which sounds like a really less number, but they also say that this saves them about 6 million cubic feet of oil annually. So it's a big savings. So KPC, it began formal operation in 2014. It was constructed in 2012, and it was formerly known as the Karangi Thermal Power Station, or KTPS. It generates 248 megawatt of electricity, so there are 4 turbines present, 2 gas and 2 steam. The gas turbines produce 100 megawatt each, and the steam turbines produce 24 megawatt each. As you can see here, this is a diagram showing KPC. So we have the 2 gas turbines here, and then we have the steam turbine here. So there's only one present, but there's another one. So the programmable logic controllers are present throughout the plant. They continuously send data to the control room for its proper operation and monitoring of the different systems. The 5 main parameters that are measured include temperature, flow, pressure, level, and vibration. Some of the common examples of these are like thermocouples for temperature, strain gauges for pressure, ultrasound wave propagation for level, and eddy currents for the vibration. So the GRS, or the gas receiving station, is one of the first parts of the plant. It is the place where natural gas is received from the SSGC, or the East West Southern Gas Company. The gas is then metered, and then it is filtered for supply to the gas turbines. So the filters that are present include scrubbers, which remove large dust particles, and other filters that remove oil that may be present. This oil can be very dangerous during the gas compression stage, which is the next one. So we have differential pressure gauges and transmitters that are installed before and after each filter, where a significant change in the pressure will indicate that the filter has choked or it has been blocked, and it immediately requires maintenance. We also have a magnetic flow type level gauge that is present to measure the amount of oil. So any oil that may be present would have to be removed for the safe operation, and then any filter can be taken out of service by using the inlet and outlet isolation valves. So for metering purposes, there is a turbine flow meter that is used to indirectly find the uncorrected volume of the gas. So the way that this meter works is that the fluid passes through the turbine housing, and as it does this, it causes the freely suspended turbine blades to rotate. The velocity of the turbine is directly proportional to the velocity of the fluid passing through it. The turbine also produces a frequency output that is produced using a magnetic pickup or the motion sensor. And this frequency, so the frequency of the pulses that are generated is directly proportional to the volume of the fluid. We also have temperature and pressure transducers to find the corrected compensated volume of the gas, which is through some calculation. We also have flow conditioners before the flow meter that converts the flow from turbulent to laminar for correct and accurate measurement. We also have an emergency shutdown valve before the natural gas compressor for safety purposes. So the next part is the natural gas compressor, where the gas is compressed before it is passed through the gas turbine. This also helps improve flow. So the change in pressures between 2.2 and 4.2 bar to 44, between 44 and 46 bar, where 1 bar is 100,000 Pascal, so that's a big change in the pressure. So over here we also have pressure sensors that are present at the input and output. We have a PT100, which is a platinum thermometer, and then we also have seismic vibration sensors. So the gas turbine is the main part of the plant. It is where the gas is combusted to produce electricity. So obviously, since this is such a big part, it has some of the most more robust and more intensive monitoring and measurement going on, not only for the safety of the equipment, but also for the safety of the employees. So here we have vibration monitoring probes, we have temperature sensors and fire protection systems, there are support bearings, we also have digital meters for electrical power values, and we have relay systems. So Vibrex vibration monitoring system was a big thing that was mentioned throughout the resource, and its working was also provided. So vibration was a big part of the protection and the measurement. And then we have voltage regulation. So the gas insulated switchgear is used to provide protection. So this is located right at the end of the plant. So once the electricity is generated and it is being sent to the transmission networks, it first passes through the switchgear where it is, which provides safety and also current measurement, voltage measurement. So that is also done here. Next, we have the open cooling water system, which contains cooled seawater that is stored in a tank and is used to absorb heat from the hot water in the closed cooling water circuit. So the closed cooling water circuit is what is in contact with the different devices and the different equipment. So that closed cooling water absorbs the heat from it is in not direct contact, but the pipes are closer to the equipment. And then that closed cooling water comes to the open cooling water circuit where it absorbs the heat from the water, and then it is deposited out into the sea. So this includes the pump. So there are two vertical pumps that are present. One is functional, one is on standby. The pumps have a flow rate of 2,600 meter cube per hour and 4.5 bar discharge pressure. So the pump motor protection relay is constantly measuring the winding temperature of the motor, bearing temperature, vibration monitoring, and level detection of the tank. So this level detection system may include a ball float that is attached to an arm, as you can see in this image right here. So the arm changes its angle as the level of the fluid changes. The angle that's made can be used to find the level according to a calibrated scale, which you can see here. The scale is also not linear. So another example of the level detection system was that there were plates that were present on the walls of the tank that moved up as the fluid rose to their level. So as soon as they became submerged with the fluid, they would rise up, and if not, then they would remain down. So then they would send a signal to the control station to indicate what the level is. So these are the references that we use for this case study. There was the K-Electric KPC internee training manual, as well as the Fundamentals of Industrial Instrumentation and Process Control, which is a course book for our course.